Hi guys, myself Ankita. In this video, you shall see another problem on LeetCode. House robber. So you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is the adjacent houses have security systems connected, and it will automatically connect the police if two adjacent houses were broken into on the same night. So given integer array representing the amount of money each house has, and return the maximum amount of money that you can rob tonight without alerting the police. So you want to have get the maximum amount of money that you can rob from the houses, but we should not alert without alerting the police. So what is the case of alerting the police? If you rob the money from adjacent houses, that will be the case where you'll be alerted to the police. So if you carefully observe, see, let's say we will grab 2 now. Okay, so pointer is pointing in the beginning of the array. Next, adjacent house cannot be robbed, so we'll grab rob 9. Since the element doesn't array doesn't have any negative elements, so all the alternative positions we can grab. So after that, 3 cannot be grabbed because it's adjacent to 9, so 1 will be grabbed. So it will be total of 9 plus 2 plus 1, 12. Fine. Another possibility will be you will not grab the first element, start from second. So it's 7. After 7, 9 cannot be there. So 3. 7 plus 3, that will be 10. So maximum of these two will be 12. So you grab total sum of 12. This is what we need to answer. So how do we approach? What's the approach to solve the problem? So if you carefully see, if you start from first, then you go to alternate positions, alternate positions. Same like if you start from second, then alternate positions. So, and the array elements are not containing negative, so grab all alternating positions elements. So if you carefully see, we can apply the dynamic programming DP approach over here. So as you all know, in DP we will be using tabulation method, so that is nothing but bottom up. So we start from the base case here. So first, let's say DP is an array, okay, of n plus 1. So first we have to calculate DP of 0. So all are initialized to 0 initially, okay. So all are initialized to 0. So first we have to calculate dp of 0. dp of 0 is nothing but the first element, grabbing only 2. So this is 0, 1, 2, 3, 4. So grabbing the first element, that is nothing but nums of 0. So if you are at first position, the only way is either you can do not take that or you can take that. So maximum of which of them? Either you are taking 0 money or 2 money, amount of 2. 2 is the highest one. So that will be nums of 0. Next we will calculate dp of 1. These two base cases, okay. So when you come to 7, this position, second position, what are the maximum money that you can grab at this position? So either you can take 7 only or you can take 2 only. So that is nothing but max of nums of 1 or dp of 0, or nums of 0 also you can write it. So, nums of 0 is nothing but dp of 0 only. So either you can take 7 or 2. So maximum of these two, what, that is 7. So you take max of dp of 0 comma nums of 1, current element, and max of the previous one. So it's basically a dynamic programming approach. So when you're at zeroth position, you have only option to choose that element, money, to grab that money. When you come to first position, either you can choose this or you can choose previous ones. So whichever is the maximum of them, that will be the highest money that we grab at this position. Why can't we choose both 7 and grab both 7 and 2? Because they are adjacent. That will alert the police. So that shouldn't happen. So we have to grab the alternate elements. Next, for the second position, start the loop for I equal to 2 to n minus 1. That is the last element. So for this position, what you can grab? Either you can grab this or the previous position element. So grabbing of this means nothing but dp of I minus 2 plus particular element. So that will be max of dp of I minus 2 plus nums of I, comma, dp of I minus 1. That is nothing but dp of I. So at this position 2, what is the maximum number of money you can take it? Either you can take 2 and 9, or else only you can take is this 7. So this 7 is nothing but dp of I minus 1, right? That is dp of 1. How do you take 9 and 2? That is nothing but dp of I minus 2, dp of 0 plus particular element, nums of I. That is 9. So that will be 9 plus 2 will be 11, and dp of I minus 1, that is 7, will be 7. So maximum these two will be 11. So at this point 11 is the maximum amount of money that can grab. Here it is 7, here it is 2. Okay, then you move here, third element. Again, okay. So again, we move to third position. So in this case, either you can grab 3, 7, or you can grab 9, comma 2. So how do you grab 3 and 7? So that is nothing but dp of I minus 2 plus particular element. So dp of I minus 2 plus particular element, that is nothing but 7 plus 3, 10. So or else 9 dp of I minus 1. At this position, what is the maximum? 11. So 11 and 10, which is maximum? 11 only. So here at this position, 11 will be the maximum amount of money that can grab. Next, you move to next house at the fourth position. Here again you check dp of I minus 1 is 11. Here dp of I minus 2 is 11. 11 plus 1, that will be 12. So max of 11 comma 12 is nothing but 12. So this is the maximum amount of money that can grab. So this is the way to solve the problem. And if you see, we are taking extra memory space of n for this array. So is there a possibility that we can restrict from taking this extra space? Yes, we do have. So what we can do is, let's say dp of 0 will be previous to, and dp of 1 will be previous. Okay, and current is pointing at the this position. So if we assign this previous and previous, instead of using dp of I, we will make it as current. That will be max of 1 is previous to, another is nothing but previous. Okay, so once you get this, so we have 27931 So initially this is previous to, previous, and current is pointing here. Now here you got, what is the sum? 11. So this is 2 7 11. So next what happens is, this previous will become previous to. So previous to equal to previous. Okay, and whatever is there in the current, that will be assigned to previous. So previous will be equal to current. That's it. So next, again new loop will be run. So at this point, this will be previous to, and here it will be previous, and here it will be the current. It will be calculated. So this is the optimization of the given problem without using any extra space. So first we will write the size. Okay. So once you write the size, first I'll implement using this array approach. Okay. Vector of type int. Let's name it as dp of n plus 1 comma 0. All are initialized to 0. Okay, this should be n. Why n plus 1 is not required? Because you're returning n minus 1 as answer. So 0, 1, 2, 3, 4. That many index array is fine. So next, after this, we shall need to iterate to the array. So first, we will write the base case. dp of 0 will be nothing but nums of 0, and dp of 1 will be max of nums of 0, or we can write nums of 1 comma dp of 0, dp of 0, or else nums of 0 only you can write. Next, run the for loop. It starts from I equal to 2 and I less than n, I plus plus. So first dp of I will be nothing but max of either the previous element maximum or the particular position. So that is nothing but dp of I minus 2 plus nums of I. So at last we need to return dp of n minus 1. So this is where the maximum 12 will be written. Yeah. So for okay, next implementation will be of using this without using the extra space. So for that, I'll just comment this for now, copy and then comment, and I'll paste the same code. So size and this dp array is not required. So we'll initialize it as int previous to. Okay. Next, this will be nothing but int previous. So max of nums of 1 comma previous to it should be. And here it should be current. So instead of dp of I minus 1, this should be previous, and dp of I minus 1 is nothing but previous to previous. So after this, at last you have to return the current or previous. Yeah. And because first we initialize previous to will be equal to previous, next previous will be equal to current. Hence previous is pointing to current apparently, so you return previous one. So we'll run this also. Yeah, and for Java also the same code. Here instead of max we have to give math.max and length instead of size. So we shall submit this also. Yeah, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in next session. Until then, keep learning. Thank you.